Hi students, Mr. Myers here. Wanted to do a quick tutorial on average atomic mass and molar mass from Friday's class. Remember, the average atomic mass, it's used on the periodic table to describe an element. We calculate it using isotopes, more specifically the relative abundance of those isotopes, which add up to 100%. So remember from Chem 1, we learned about isotopes, which are the same element, but they differ in the number of neutrons. Neutrons have no charge, but they do have mass. So as we change or have several isotopes, it's going to be the same type of element, but different masses. And then if you take a sample of that element, each of those isotopes is going to be in a different quantity or amount, which is the relative abundance part. An average atomic mass is determined or calculated like we would do a weighted average, much like your overall course grade. So let's say assessments are 80% and classwork is 20% of your overall grade. If you have an overall assessment grade of 89 and classwork grade of 94, we will calculate your overall grade the following way. We have 89, let's say 89 is your assessment grade times that 80%, and then the 94 for the classwork times 20%. Notice that we are converting or changing the percentages to decimal form. That's important. So we do the math, and when we add them together, we come up with 90. Oops. So 90 this. There we go. So 90 is your overall grade. All right, sorry about that. So average atomic mass, the calculations are going to be completed the same as your weighted grade. So let's look at this example. It says determine the average atomic mass for carbon. Carbon-12 is approximately 99% of all carbon. Carbon-13 is about 0.8%, and carbon-14, which is used in radiometric dating, makes up about 0.2%. Again, don't forget, since we are multiplying the mass number by the percentage must be converted to decimal form. So you can do that by dividing by 100 or move the decimal 2 places to the left. So 0.8, 2 places over gives us 0.008. So we have the 12 times the 0.99. We add that to the 13 times its 0.8% here, 0.008, and add that to 14 times 0.002. These are each the different weights depending on which isotope we're looking at. And when we add them up, we get a total of 12.012 AMU. AMU is atomic mass unit. So don't forget, at this point going forward in the class, we're doing a lot of applied math. You must include units. The units are very important. Average atomic mass is also the molar mass of that element, which is very convenient for us, very helpful. This means that it's the mass of 1 mole of that element, which has the units of grams per mole. Now, mole, we'll learn more about in the coming days. Mole is an SI unit that measures a quantity of particles. Okay, and we've talked a little bit about Avogadro's number in class. 6.02 times 10 to the 23rd particles is 1 mole. And we'll look at that more coming up in the next few days. As an example, if we were to take oxygen from the periodic table, the average atomic mass, which is accounting for all the isotopes of oxygen, is 16 AMU. If we reapply this in terms of molar mass, we say that it's 16 grams per mole of oxygen. And to calculate the molar mass for a compound, we simply add up each element's molar mass. For example, let's look at water. Water has 2 hydrogens and 1 oxygen. If we take the 2 hydrogens times the molar mass of each, 1.01, and then oxygen 1 times 16, we get 2.02 for hydrogen and 16 for oxygen. Add them together. 18.02 grams per mole is the molar mass of water. Let's do another example. we have potassium carbonate, K2CO3. Go ahead and pause the video and work this out on your own. All right, so if you paused it and you come back, I gave you a few seconds there. We have two potassiums. Each one is 39.10 grams per mole from the periodic table. Carbon, we have one of them at 12.01 grams per mole. And oxygen, we have three of them at 16.00 grams per mole. If we do the math, these are the parts that we get. And then we add those three values in red together to get 138.21 grams per mole. And that's the final answer. This is the molar mass of potassium carbonate. Email me or let me know if you have any other questions. Thanks.